Okay, welcome back to lesson 4 of our introduction or overview of the course Networks and Distributed Systems. Let's pick up where we left off in the last lesson. Coaxial cable, like twisted pair, consists of two copper conductors, as you can see in this graphic here. But the two conductors are concentric rather than parallel. With this construction and special insulation and shielding, coaxial cable can achieve very high data transmission rates. Cable television systems have been coupled with cable modems to provide residential users with internet access at rates of tens of megabits per second. In cable television and cable internet access, the transmitter shifts the digital signal to a specific frequency band, and the resulting analog signal is sent from the transmitter to one or more receivers. Coaxial cable can be used as a guided shared medium. That means that a number of end systems can be connected directly to the cable, with each of the end systems receiving whatever is sent by the other end systems. One problem with all these forms of copper medium is that they can be impacted by environmental interruptions such as power surges caused by lightning or equipment failure. Also, the medium itself suffers from attenuation. Attenuation is the gradual loss of the signal flow through the medium. Attenuation affects the propagation of waves and signals in electrical circuits. Copper cables are also pretty easy to tap. Optic fiber is a thin, flexible medium that conducts pulses of light, with each pulse representing a bit. A single optical fiber can support tremendous bit rates up to tens or even hundreds of gigabits per second. Unlike copper, it does not suffer from electromagnetic interruptions. It has a very low attenuation, up to 100 kilometers, and it's very hard to tap. These characteristics have made fiber optics the preferred long-haul guided transmission media, particularly for overseas links. Many of the long-distance telephone networks of the United States and elsewhere now use fiber optics exclusively. Fiber optics is also prevalent in the backbone of the Internet. However, the high cost of optical devices such as transmitters, receivers, and switches has hindered their deployment for short-haul transport, such as in a LAN or into the home in a residential access network. The optical carrier standard link speeds range from 51.8 megabits per second to 39.8 gigabits per second. Radio channels carry signals in the electromagnetic medium. They are an attractive medium because they require no physical wire to be installed, can penetrate walls, provide connectivity to a mobile user, and potentially carry a signal for long distances. The characteristics of a radio channel depend significantly on the propagation environment and the distance over which the signal is to be carried. For example, you may find that you cannot get a signal in certain buildings for whatever reason, or you may lose a signal as you pass through a tunnel, indicating poor propagation environment. Terrestrial radio channels can be broadly classified into three groups: those that operate over very short distance, 1 or 2 meters, and those that operate in local areas typically spanning from 10 to a few hundred meters, and those that operate in a wide area spanning tens of kilometers. Personal devices such as wireless headsets and keyboards and medical devices operate over short distances, like your Bluetooth. The wireless LAN technologies described previously use local area radio channels. The cellular access technologies use wide area radio channels. And then there's the satellite. A communication satellite links 2 or more Earth-based microwave transmitters known as ground stations. The satellite receives a signal from a source host on Earth, regenerates it, and then transmits it back to the destination. The satellite receives transmissions on one frequency band, regenerates the signal using a repeater, and transmits the signal on another frequency. So we see a couple of terms there. The satellite receives the signal from a ground station, and it uses a repeater to send that signal back to Earth. Two types of satellites are used in communications: geostationary satellites and low Earth orbiting satellites, usually abbreviated LEO or LEO. Geostationary satellites permanently remain above the same spot on Earth. This stationary presence is achieved by placing the satellite in orbit at 36,000 miles above Earth. This huge distance from the ground station through satellite back to ground station introduces a substantial signal propagation delay of 280 milliseconds. However, satellite links can operate at speeds of hundreds of megabits per second, often used in areas without access to DSL or cable internet access. Low Earth orbiting satellites are placed much closer to Earth and do not remain permanently above one spot on Earth. They rotate around the Earth and may communicate with each other, as well as the ground station, to provide continuous coverage to an area. Many satellites need to be placed in orbit. There are currently very many low-altitude communication systems in development. We're going to move to another topic here, so this would be a good time to take a break. Go ahead and do whatever you need to do, complete any other assignments you've got going on with us, and when you're ready to start the next one, come on back.